Thanks, everyone, for joining. My name is Nate Miller. I am the founder and CEO of Proving Ground. We're a digital design agency kind of based in the Midwest region. I'm in Omaha, Nebraska. We have kind of a team that's sort of spread around in Iowa, Minneapolis, Oklahoma, South Carolina. And at the end of the day, what we're interested in promoting and being advocates for and helping with is this idea of helping the building design and construction industry become more data driven. And this oftentimes manifests itself through a number of different ways with which we engage with the building industry. And I think one of the bigger ideas here is that being data driven is more than just having access to data or leveraging specific technical workflows. It really does speak to this idea of having a methodology and promoting cultural shifts that allow us to think about things through evidence-based workflows and decision-making processes based on the use of data. And I think that's especially relevant when we think about our topic today with business intelligence. Business intelligence is in many ways a layer on top of various data frameworks that can be used to help drive decisions and actions through kind of insightful uses of analysis and visualization of the data that we have. But what I thought I would start with is just maybe a bit of a set of observations on data in the world of construction and building and design. It's something that I feel a lot of people talk about in a very abstract sense. One of the things that we hear from our clients and hear from our customers is that, hey, we have a lot of data. What can we do with it? Or there might even be sort of passing references to, hey, we're using data for X and data for Y. And there is sometimes less of a dialogue about the direct engagement of how the specifics of how data can be put to use. And I think there's a number of reasons for that. And I think a lot of it has to do with complexity of our industry. Any given project that we work on in the building design and construction industry has multiple sources of data spread across many different forms of representation. I think any given project may be dealing with dozens, sometimes hundreds of different data sources at any given point in time, right? And our tools today are set up to kind of manage data in kind of very localized circumstances. So when you're building a Revit file, you are in effect authoring data using building information modeling. When you run an analysis of your building, using daylight simulation, you're kind of using available data about climate and using simulated data to kind of make predictive assumptions of how your building may perform relative to certain criteria. And there's also just the idea of a plan, right, or a spreadsheet of any kind. These are different forms of data that we're dealing with. But that scope goes oftentimes out into the stratosphere when we think about larger project teams. I kind of put together a set of diagrams here that look at where is the data. For example, we have data sources that are spread across multiple different tools, multiple different platforms. There are databases that we are actively having to access. The data is growing, it's shrinking, it's evolving over time. And no two projects may deal with the same set of data sources depending on what region you're operating in, what tool sets your collaborators are working with, and so on. So there's this kind of spread out, kind of disconnected set kind of landscape of data that is always kind of in motion, right? There's also like this idea of who owns the data in our industry, and this is a very complex question to unpack. And a lot of it comes back to contracts and liability. Who's authoring? How is data being handed off? Who has access to certain forms of information? And again, these paradigms may change project to project, and they may change from organization to organization. And then So from responsibility to then relating data sources becomes kind of an interesting kind of study to do. So if we have this landscape of data sources and these kind of changing sets of roles and responsibilities and levels of access to this information, the way with which data relates may also become this moving and evolving system of relationships. So, your space plan or your spatial information about a project's performance may relate differently to a costing model or a set of costing models as a project evolves. And so figuring out how that information can be joined up with other information, or how data about your design may be linked up with data about an analytical system. So there are these different relationships that kind of have to are always kind of moving in an evolution. So you have this idea of data sources, data owners, data relationships, and then there's, I think a very kind of important and profound question to all of this is who is really using this data, and what and how can we start to equip people with data in a way that they can make certain decisions. And one of the things that we like to promote in our idea of digital transformation, for example, is that data and technology more broadly, or any kind of form of digital tool set, goes beyond one set of stakeholders. And I think, if we look at kind of dialogues about design technology today, oftentimes, we have, you can see like a group of people that, might be those sort of in that implementer and kind of expert wizard category of user or of expert. But there is kind of a larger need across the spectrum of people and stakeholders for the ability to use information in different ways, which starts to really speak to a very specific, kind of a different set of needs, and maybe cause us to shift our thinking a little bit in terms of how can these capabilities become democratized and expand beyond the specialist, for example. So here you have kind of this spectrum of people that may exist in any given organization. And so you might have people that are really developing novel integrations and connections and visualizations for enhancing data-driven processes. These are the experts that are out there. And of course, you might have people that are growing the adoption of data-driven processes internally through training and knowledge development. But we also need to think about how can general team members, people that are users and might be authoring models or authoring different data sets, be able to use data to support quality, economy, and performance of their projects. And how can we then equip managers with data that can help them evaluate the performance of their projects and optimize their delivery processes, even down to then the executive, to really use data to capitalize on market trends and really look at the performance of the company. So there's a sort of spectrum of need that we observe out there. And when we think about data in the building industry, and business intelligence in particular, it's really, in our view, kind of how we impact this kind of larger swath of stakeholders, right? And so when we think about then the larger problem with all of this and kind of where we look at driving our conclusions, there's this need for dynamic, adaptable workflows. We need tools that can be leveraged by experts and non-experts in any given point in time. There needs to be a way with which we're able to bridge digital skills gaps and sort of what we would characterize as low data literacy. I certainly didn't go to school in architecture to learn about data, and I think that can be said discipline to discipline within the space of our construction industry. So how do we figure out and get people to kind of understand this? And then overcoming the aversion to adopting new workflows is another kind of thing to consider. This idea of getting people to change behavior, think about new ways of working, and overcome some hesitancy of doing something a new and different way is I think something that affects just about everything in our industry. So that kind of leads me to this idea of business intelligence, and this is really a class of concepts that is really very much informed about this need to connect and correlate and create predictive views of organizational resources. So one definition of this is this idea that you have enterprise tools that can provide historical correlated predictive views. And so you can kind of start to imagine interfaces and ways with which we're able to work and connect to a multitude of data sources that will allow us to engage in this kind of very complex landscape of sources, ownership, and relationships, right? And this manifests itself in the form of tools that really accomplish three things. One, tools that can facilitate analytical content development, so creation of reports, creation of dashboards, and kind of or I guess a more as a practical description of what you might see as content being developed. There's tools that let us navigate the idea of data access, preparation, interaction, and collaboration on data sets. And I think one area that we're very interested in is this idea of data-driven processes that are aimed at non-technical users. And we certainly see this growing as a trend, this idea of no-code or low-code interfaces. And it really started back with Excel as a, when that program came onto the scene, all of a sudden you had this tool that took this idea of data management and working with spreadsheets from a very kind of niche, kind of analytical specialist type of tasking to now what you see today is 750 million users of Excel because of that kind of lowered barrier to entry. And we're starting to see the same thing occur with business intelligence. So this idea that you now have interfaces that can allow experts and non-experts to connect to a multitude of sources and construct reports and construct visuals that allow one to make decisions about a given problem or kind of report and understand metrics that are important to them such that they can derive actions and deliver outcomes. And so I wanted to just maybe start with maybe this example here. This is a dashboard that I put together several years ago, maybe in the early days of Proving Ground, that connects information about a set of real estate sites with information about digital assets derived from building information models on a common dashboard published to the web in Power BI. And this dashboard here is built without a single line of code written. It's composed using kind of more conventional user interfaces, drag and drop interfaces, connect and relating data together. The kind of mode of representation here is still very abstract. I think for a designer or a builder, I mean, we're looking at pie charts and scatter plots and tables and things like that. And so, but at the same time, there's what I started to see and what our team started to see at Proving Ground is a sort of potential of being able to say like, wow, well, there is this opportunity to really leverage this interface that's being used in accounting and finance and other kind of forms of big data analytics to kind of really attach it to the building, design, and construction industry, which kind of leads to the main topic of today, which is business intelligence for designers and builders. And what we're really interested in here is positioning BI as a concept for delivering insight and outcomes with design, construction, and operational data specifically. And we think that needs to, that takes shape through a number of different mechanisms. First is like we can leverage technology that's already on the market and already has a very large surface area in the space of business intelligence. So our aim is not necessarily to reinvent a new business intelligence paradigm per se for architecture specifically. We think that we can take this premise that has a kind of large surface area of users and knowledge, and build around that and build integrations into the type of data that design, construction, and owner operators are familiar with. So I'm going to go through a series of examples that kind of looks at this, and a lot of these examples are built on some tools that we've been making at Proving Ground under the banner of PG Apps that really look at these types of workflows. And some of our objectives with these tools is to really think about ways with which we can lower the barrier to entry for data in architecture, engineering, construction, and owner operation. We are aiming to really position these tools as a way to grow analytical skills among professionals. We're also looking at ways with which we can create insight from the data that we have. Again, going back to the idea that we have a lot of information. I don't know the extent that all that information is being fully leveraged or is at a level of quality with which it can be leveraged. So it's really about how can we get insight into that information. And then can we start to leverage industry-specific information and provide modes of representing that data that we're familiar with? So the idea that we can take two-dimensional and three-dimensional information and really integrate it in with other sources of data and correlate it.
Nate, as you're getting into these examples, I just wanted to note for folks listening, feel free to use the Q&A panel to ask questions that we'll address when we've got some pauses throughout the presentation.
Great. Thanks, Steve. The examples that I'm going to go through are going to really look at, I guess, these four areas. And maybe what I'm going to try to do is articulate some use cases for how a business intelligence type of platform can be used to really look at our data in maybe new and novel ways. Our group in particular has been focused on really, I think 3 tools in this space in particular, just because of their widespread use in a lot of the work that we do personally, but also just in the kind of market context that we operate in. So we know that and have a lot of experience in uses of Rhino as a kind of a 3D modeling environment and computational design toolkit. Revit as being the market kind of leading platform for authoring building information models has been an area of focus. And then Power BI has seen a great deal of adoption within the architectural design and construction world, primarily because of how Microsoft has been able to position this alongside other familiar and highly democratized tools like the Office suite, Excel, and so on. And so these tools become very kind of accessible and tangible sort of departure points for understanding how these things can start to interact. And what we've done is we've started to build a couple of tools now that look at those integrations. So we've published Semantic, which is a tool for Rhino that connects Rhino data to Power BI, and then also a tool called Tracer, which connects Revit's building information data into Power BI as well. And so as I go through these examples, I'm going to maybe highlight how the source information is kind of curated a bit, and then how that data then gets put to use for different use cases, right? So I'll start with Semantic and just really talk about this integration in specifics, this idea that as a designer or as someone that's using Rhino, you're building up 3-dimensional geometry that may have data, it may not have data, and it's kind of a free-form editing environment. And what's interesting about Rhino is that the file format for Rhino itself is open source. You can access the contents of a Rhino file externally of Rhino. You can really get into the guts of the file and access geometry. And they've published a wide variety of resources for doing this, including JavaScript libraries, C# libraries, and other connections into their APIs. And so with Semantic, our kind of goal here was to really think about, okay, well, if you have this kind of free and very open-ended modeling environment, can we start to think about ways in which data can be integrated into that environment itself? And we've introduced different tools and widgets for like property editing and adding information, metadata on top of objects, just to kind of provide a layer of data richness onto your Rhino files, as well as a set of kind of reporting tools that lets you understand maybe some different parameters and quantities that exist in any given file at a conceptual level, but also we've seen these tools being put to use in our fabrication and later stage construction workflows as well. But where this becomes interesting for us in the context of business intelligence is that all of a sudden we're thinking about the Rhino file as more than just a model to produce a given deliverable, but we're thinking about it in the way with which that model can be used for different forms of analytical and communication purposes. So what you're seeing here is Power BI, the Power BI environment, and using a set of three-dimensional visualization tools, as well as the more out-of-the-box visualization tools by way of pie charts and bar charts. We can develop an interactive three-dimensional dashboard that communicates metrics that we're interested in understanding. And we're able to do so without having to write a single line of code or HTML to get to the end result. And we think that's a pretty powerful idea, the idea that you could go from a conventional modeling paradigm, just modeling surfaces in Rhino, maybe applying some attributes, to then taking the information, tying it into a business intelligence environment, bringing in other data sources as well, composing a dashboard, and then getting to a state where you have something that you can share with other stakeholders. With a kind of very low, I would consider in the space of technology, very low barrier to entry. So something like that Rhino model that is just a set of surfaces might be transformed and composed into a report that looks like this, where you have a three-dimensional breakdown of surface areas and building program. You can start to get an understanding of different metrics that may be impacting the project, like cost per square foot, or area of building, potential revenue generation. And what we're able to do beyond that as well is then start to think about how that information gets shared with others. And so here's a report that is generated from a kind of an evolved set of information points published to the web, and looks at the idea of option comparison for early design. So here you have 4 options that are being composed in the dashboard. The user is able to select which design options they want to highlight, and then understand associated metrics and comparables to those design options. Something that's, again, able to be composed and put together by a professional, and perhaps even a non-technical expert professional, and have it be something that is a digital asset that communicates a set of objectives. We've seen this type of thing kind of applied in the space of maybe more kind of fabrication level building systems. So complex geometry. This is a sketch that I put together for these types of presentations that looks at a kind of parametric truss structure, 3 options generated, color gradients that are kind of suggestive of panel flatness, and we're able to kind of get an understanding of the composition of these elements, again in a kind of a web viewable formatted dashboard that tells that specific story. And there's other kind of applications for this that even maybe goes beyond our particular domain and expertise. And those that know me well know that I'm a huge nerd. And I have, maybe I have a hobby in the space of 3D printing. So for anyone out there that's familiar with kind of prop making and classic movies from the 80s may recognize this particular toy from a model that in the 80s. I certainly had this toy as a kid growing up. This is the Ghost Trap from the famous Ghostbusters franchise. I'm really into 3D printing. I make stuff for myself and my kid all the time. So this is a 3D printable set of files organized in Power BI, showing breakdowns of component parts and assemblies, as well as information about the particular 3D printable material being used, the layer heights being used by the 3D printer, and then a set of instructional steps that can guide you through the composition and build of one of these given props. And so again, taking us away from architecture for a minute, but just kind of showing maybe something that's suggestive of some potential workflows and uses here at a conceptual level. So I wanted to now kind of step into the space of, if that's kind of the conceptual kind of realm of, or kind of the early stage development, or the freeform geometry realm of 3D modeling and representation, what we can also observe in the building industry is that one of the central sources of data that we work with day in and day out as professionals is that of building information modeling, right? So as professionals, based even across different platforms and tools, you are authoring and composing more likely than not some aspect of BIM, right? So you might be in Revit doing planning, you might be in a place like Tekla doing kind of steel detailing, you might be in ArchiCAD, et cetera, et cetera. Revit at this point in time obviously is one of those tools that is extremely widely adopted, especially in North America. And we wanted to really look at ways with which we could equip users of Revit with ways of harvesting their information, both at a data level, but then also at a 2D and 3D level, and have that data represented in the business intelligence environment like Power BI. So the workflow that we have here is mostly about how do you translate a Revit file into a data source. Power BI isn't going to read your Revit file directly, right? You have to get the data out in a way that a tool like Power BI can connect to it. And so there's an aspect of this where we've invested quite a bit of time and energy into creating harvesters that let us take these industry file formats and put them into kind of open database modes of representation. So one of the things that Tracer out of the box does with this toolkit is takes your Revit document and composes an SQLLite database. And using open database connectivity paradigms with Power BI, you can connect to that database and read in different attributes about your project, about the geometry, about various parameters, and so on. And so what that results in is this ability to connect into a building information model as you would an Excel file, or as you would a CSV or a JSON file in Power BI, and using the kind of drag and drop interface and visualization tools that we have authored, we can now display the information right out of the data source and have it dynamically generated within a dashboard environment. So this is, there's two visuals here that you can see. One is like a two-dimensional vectorized visual that's looking at spatial boundary information and is generating a view of that data through the drag and drop allocation of fields. And then using the same data source, we're dragging and dropping three-dimensional mesh geometry onto the dashboard as well. All of this is happening, I guess, on the client side. And what I mean by that is that we're not relying on any kind of third-party service or subscription service to like BIM 360 or Forge to accomplish this. This is all kind of being kind of composed, on the kind of in the kind of user's environment as a standalone workflow, which we think is pretty important to consider in a depending on your objective, of course. So a couple of use cases for this. We've seen a lot of interest in the space of real estate to kind of understand a building information model asset and have it tied into other systems. This is a dashboard that was composed to look at available office space in kind of a co-working environment where you have different offices, open areas, and program areas. And what we've done is we've taken the model information and tied it into information about, hey, monthly revenue, occupancy level, leased or unleased or available spaces. So using a dashboard, which in this case is published online as a sample here, you can access and start to get some information about these available spaces. And using kind of the interactive nature of Power BI, have a device and a tool that you can start to scrub through and kind of understand the trade-offs, the availability of different areas, and what that amounts to in terms of dollars and cents for a particular business model. We can extend this kind of concept into three-dimensional representation. So this is, again, taking the idea of space. This is a sample model that comes with Revit, harvested in the context of Power BI through the Tracer toolkit. And here you can see a set of three-dimensional volumes being represented with square areas being depicted in a dashboard context. So it can go beyond that kind of the 2D again into kind of a 3D mode of understanding the digital asset. But that kind of lends itself to then thinking about different use cases. So maybe it's going back to option comparison. This is the idea of taking design options that might be baked into your Revit file at any given point in time. These are a couple of like small office fit outs. And using Tracer, we're able to kind of parse the design option information and provide dynamic views that lets us look at comparative information about how might this potential space get laid out. And we can see the different digital assets present within the BIM file presented here by way of different content that's selectable and can present different information back to the user. And the three-dimensional access of content is something itself that is a kind of a very valid use case. It's a question that's come up on the owner-operator side a bit, as well as from architects that are dealing with some level of three-dimensional content analysis in their model. This is a Power BI dashboard that's using harvested model information to visualize and create a content explorer. So we're able to drill down into specific digital assets, pull their parameters, pull their three-dimensional information, quantities, and so on out of the model, and start to navigate it. And then this idea that the data within these building information models may be need to be correlated and connected to other sources like scheduling information, costing information, on the kind of construction end of the spectrum. This is again, using the same set of tools, Tracer and harvested Revit data. We have a three-dimensional model of a building. These elements are tied in with a database related to their timeline of projected construction schedule, and we're using a Power BI visual for slicing through a timeline to kind of show potential progress of a construction job, right? This is obviously kind of a very conceptual example, but this idea that hey, we have a three-dimensional digital asset, we can tie it to information about time, and then we can use the tools available to us in business intelligence to correlate those assets and bring them together to provide a view and start to tell a story. And these use cases are numerous. We have this ability to compose dashboards, tell a story based on the need of the project, tell and articulate a use case that can deliver value in its own context at a given moment in time. These are meant to be flexible tools and not prescriptive and only showing us one view of information, but allowing, by building these tool sets out for, tools like Power BI, you can connect into a number of different things and present the information that you as someone that might be involved in a specific discipline is interested in, or someone that might be a project manager, what you might be interested in. It becomes another way of composing your story with the information. I'm going to pause here, and maybe if there are some questions we can maybe talk about before I get into the some of the opportunities that we are seeing beyond maybe this specific tool set and some of the current research that we're doing and how business intelligence may be leveraged and involved in our world and our space in the future. So Steve, if you would moderate.
Yeah. Well, so we have a couple of questions about file types. There's a lot of interest on IFC, ArchiCAD, and Autodesk Assemble. If we have any plans for those platforms.
Good. That's going to be the next section. So I'll talk about.
Oh boy.
I'll talk about
so
that
exciting.
Next.
Great. Let's see here. Someone asked if you were a Ghostbuster.
Am I a Ghostbuster?
Are you? Can we call you if we encounter a ghost?
Who are you going to call? Proving Ground.
We're going to call Nate Miller. We had some questions about limitations in terms of performance and model size.
Yep. So that's a really good question. I think maybe some of the examples I will be showing can start to address that a little bit. Just last night, I was working with a Tekla model in our viewer with a great deal of success. Obviously, we're dealing with a visual that's sitting inside of Power BI, and we ourselves are always looking to kind of optimize our visuals performance. But last night, I was pleasantly surprised to have thousands of beams with nuts and bolts and weld lines being represented inside of the Power BI environment. There are like little things with Power BI itself when it comes to like data limits on how much data can be kind of, I guess, parsed out of like an Excel cell or a database field that we have workarounds for. But in general, I would say we've been able to go pretty far with this idea of, hey, we're going to parse information out of Revit and we're going to have a visual that's robust enough to display a good chunk of it. Now, obviously, if you're throwing Revit files that are gigs in size and you're harvesting every single element out of that model, and then you're trying to pump that into Power BI, you're going to get into some choking, I would say, in different cases, especially if you're trying to render that all at once. But I think on the other side of that is that there's also an aspect to data management, and this kind of comes along with data literacy question and the idea of understanding your objective. If I am trying to tell a story about a large scale project and I'm only concerned about spaces, the sort of tactic then is to think about, okay, well, can I isolate a set of data that will help me tell my story and get me the insight I need without having to get everything? And I think there's it becomes a strategic conversation. It becomes a conversation about use case and really thinking about what type of story are you really trying to tell with your information, and can you really start to tailor then your presentation and the reporting of that information accordingly, so you're not getting you're not unnecessarily pulling millions of records that don't really apply to your story. So I think it's a matter of data literacy, digital literacy, and being specific about your intent.
There's one more before you can move on to these opportunities, Nate. There was a lot of interest in understanding how you did the timeline. What data did you add to your Revit model? And looks like you leveraged a timeline visual that's available on the app source in the visual store in Power BI.
That's right. So there is a there's a timeline visual that's on the Microsoft Store. It's free. You can download. And basically what you're able to do is put a set of dates into this timeline and then scrub through those dates. And what's happening in that visual, maybe I'll even back up 2 slides here just to get back to it. What's happening here is that within Power BI, let me get to there we go. Get to play. Within Revit, you have elements, you have element records. Those element records have identifiers on them. And if you're able to, either within Revit or adjacent to Revit in a separate data source, be able to assign date and time information, might be start date and end date, it might be anticipated installation date, to your element, you can then use in Power BI the timeline as a filter for your model. So what's happening here is we have, within Power BI, the model, the elements are all there. And the construction timeline visual, which is a timelining tool, is filtering the elements based on the date. So we've made a join between information about time and information about elements, and Power BI kind of handles the rest. It's able to sort of say like, okay, now you're filtering based on this attribute.
Great. I'd say chat about the opportunities, and we'll see what other questions come our way.
Great, awesome. So on the opportunities, some of the things that we're looking at, and these kind of relate to questions that I think have already come up, but questions that come up pretty frequently. The stuff that we've put out there and published that you can download like today really are about kind of standalone workflows that you can leverage on your desktop and compose within your kind of ecosystem of Power BI, publishing to the web, Revit, and so on. They don't rely on, external systems or infrastructure. But what we do have, and what we have implemented and deployed at enterprise levels, is this idea of positioning building information models and other related sources in a kind of data warehouse context. So it's no longer about model to model on demand harvesting and visualization, but it becomes about infrastructure and systems that allow for multitudes of documents and multitudes of models to exist in a common data source related to other data sources such as project management, cost, and so on, in a kind of warehouse environment that can then be accessed by business intelligence. So we've constructed portals that allow for models to be submitted to the database. Multiple models exist in this data environment and that are then accessible and through, by Power BI from this kind of centralized space. More recently, and I think this is new as of this week, really, a bit of personal R&D on my side, building upon a lot of the research and development work that's been done by the Proving Ground team. We've been long talking about what does it mean to support file formats like IFC in this workflow, and can we start to really leverage these open BIM standards in a similar way that we're harvesting Revit information, which all of a sudden opens us up to being able to support data that might be coming from ArchiCAD, Vectorworks, Tekla, and so on. So this video is a very a very simple thing that I think I posted up early yesterday. Just a handful of wall elements, floor elements, door elements. These are composed in an IFC file with IFC classifications and data properties, visualized using the same tracer visual that's being used to visualize Revit data. And we're now looking at the composition of IFC as a data source, right? This has been very promising in a short amount of time. Found a couple of kind of crazy sample files online that have IFC elements. This is a mechanical system model that we recently tested and pushed through the workflow. So the study escalated really quickly. From a handful of doors and walls to an entire mechanical system being visualized in the Power BI workflow, again, with the ability to connect it into other data sources. So here you have the element and parameter records and a three-dimensional visualization of the model existing in the Power BI environment. And then to kind of even further stress test this thing, we pushed in a Tekla structures model that was generated from Tekla to IFC, and then kind of this idea of zooming in, you have all the steel detailing being represented in your Power BI dashboard. and with all of the kind of benefits of having the digital record there and accessible within Power BI, you can start to, create visualizations. It starts to speak to quantity of elements. And if there's information about materials, other parameters that relate to the quantification of elements, all of that stuff becomes exposed as any other data source would be within the Power BI environment. And again, like this idea that, we really start to use our technology with the business intelligence environment to support these open file formats, really starts to, I think, cast a wider net over potential use cases for combining three-dimensional data that the construction industry uses with this kind of overarching layer of business intelligence that's really built to connect to multiple data systems. I wanted to end on the opportunity section just looking at this kind of overarching theme of predictive modeling. So, in the business intelligence sense, you're really giving the user of business intelligence this opportunity to connect to data, look at trends as a human, look at this ability to, understand the data in different and meaningful ways. And one of our projects, I guess it's been kind of a multi-year kind of project. We tangentially work in this space and, find different use cases for it, is in the space of machine learning. And one of the central theses of our work is that concepts like machine learning and AI, the success of these concepts is predicated on the availability of well-structured, well-curated data. And if I go back to some of the initial observations I had about data sources and different forms of ownership, the way with which projects are conducted and created, our data as an industry is extremely messy. But what we see as an opportunity is to say, if we're able to really leverage these data sources and get more eyes on the information and study the information in a way that allows us to, curate well-structured data sets reliably through, reporting mechanisms. We kind of, cast a wider net on people that are able to participate in this space. Then perhaps we can start to really use a building information model database as training data to make predictions. And there's a handful of studies that we've done. This is one that's looking at machine learning and the availability of databases full of BIM data as a mechanism for data remediation. So teaching an algorithm what makes for good data quality and standard classifications, so that those classifications can be reliably applied to other projects that may have lower quality, for example. But there's also like just this idea of, if we're able to capture information in this data format, can we start to leverage building information to make predictions that might impact design? This is one area where we took a selection of 100 floor plans and trained a machine learning algorithm on sort of different attributes about these floor plans, and now provided a set of inputs and set of requirements. We can generate and predict a given layout, right? This type of work is being done pretty broadly at this point. There's a lot of different I think technology groups and research that's happening in this space. But again, like this idea that if we're able to provide frameworks that allow for this sort of data curation to occur about space, about attributes of space, and have it be reliably structured, it all of a sudden opens up opportunities for automation that didn't previously exist. But at the end of the day, like what we're about here ultimately is this idea of connecting designers and builders with their data. Not just but because we do believe that there is an opportunity to create a better built environment by reliably structuring our information, connecting to different information, being able to see our data in a different way, draw the correlations that we may be unaware of or need to see more reliably to make better decisions. And that's kind of what our aim is here with this as an overarching theme. I'll pause here, and if there are any other questions, we can cover them, and then maybe I'll give one final session where you can go to find more info.
Sure. So I was able to kind of blast out some answers to the Q&A panel. There's a question about education discount.
Mm-hmm.
I'll point folks to our apps.provingground.io website. Go ahead, Nate.
Do we have one, or they want to know what it is?
They want to know what it is.
Okay, cool. Yeah, so we do offer educational discounts, and what I'll do is I'll go through I'll go through a very quick sales pitch that covers some of that information that I think will relate to that question.
We had a question about IoT. How is that impacting our approach to these tools and services?
Well, I think that's IoT is one of those areas that is very much relevant to the space of business intelligence. So like if we are dealing with the space of smart buildings and we have these smart components that are reporting information about their state, and we're getting this stream of data about light bulbs, security devices, mechanical systems, building performance. This data is being kind of injected into our and being kind of, I guess, exhausted from all of our buildings. And we need systems with which we can access and connect to it, I think. And wouldn't it be interesting to be able to say, hey, we're going to use the IoT network of this particular facility, tie it to a reliable building information model, and now we have a way to really visualize and understand both the kind of geometric asset alongside the sort of more performative data that's coming out about the information. So I think the space of IoT combined with BI is an extremely rich one, and a prime example of the need to be able to connect into multitudes of data sources and correlate them.
We had a detailed question about connecting SQLLite files to the Power BI online service. And you've been publishing our example dashboards that have connection to SQLLite. Mm-hmm. But in your experience, Nate, if you update the SQLLite file, do you have to republish that dashboard to get the up-to-date information on the service? Have you used the gateway? Do you have any thoughts on that in terms of updating the SQLLite file and getting the dashboard up to date?
I haven't used the gateway to so the intent of SQLLite, and I guess the intent of the tool that you can download, the Tracer tool that you can download, is that it's meant to be pretty self-contained as a workflow. There's no kind of infrastructure requirement of having like a database server and like a client connection to that server. So it's really built around, the availability of a file. We have seen some folks use a combination of like OneDrive and SQLLite to use the gateway, much like you would with an Excel file. I believe that is a possibility. When we look at the kind of online service and the sort of need to have maybe live stream data that's being updated dynamically, you might be stepping into the space where you need a database, a proper database server, like MySQL, SQL Server, Postgres, or what have you, to really store and contain this information, which is something that we bring to bear in a lot of our more kind of enterprise level engagements in this space, is to really think about, okay, can we centralize the data as a resource that can be used in this manner?
Two more questions, and maybe we missed this. Did you speak to the IVC Tracer and timeline for testing on that?
Oh, yeah. So I'll pull the curtain back a little bit on the IVC thing.
I just did on accident. Sorry.
Yeah. So the idea of testing and the availability of that. So we've had the Tracer version that's up right now that connects to Revit. We've had that up for a couple of months. The 3D version was released in January, and it was really just in the last 2 days where I built the IVC Harvester. So it's still very new, I guess, and it really does show that the potential is there. I think we'll be able to get that to market and available. I'm thinking about running a beta with our current Tracer customers that have already started to adopt the Tracer for Revit environment. So if you're a current customer, I think the thinking there is maybe we'll make the IFC one available as a beta. But I think to me, the timeline is likely, I'm going to just sort of loosely say mid to late summer is when we might have a kind of product that can be trialed and downloaded. So the code right now is still very young. It's like, literally on Monday, I was like, I'm going to try to parse an IFC file and stick it into Tracer. So
you're one of those wizards, right, Nate? You're a wizard. We all know that.
Okay, thank you.
And so the last question was, and you had talked to the machine learning and AI, but there's a question about predictive modeling happening in Power BI and Power Platform and those other sort of cloud systems that could be integrated. Any thoughts there?
Well, I think so. What's intriguing? It's kind of funny. Like we in the back of my mind, and I know we just sort of maybe a bias. Like we think of Microsoft, we think of Windows, we think of Office, we think of these very sort of prosaic, if not a little mundane, concepts for how we use their tool sets. But what's really exciting to me in how they have positioned business intelligence in particular as one aspect is that they've said, like, we have 750 million Excel users across the world. That's a large footprint. Can we start to use that platform and framework to deliver business intelligence at this, at the same scale? And we're going to use that surface area, and which they're being very successful with. So with Power Platform, everything's about power with Microsoft. It's actually kind of unnerving, I have to say. Like, it's all about power. But with Power Platform, you have kind of this ecosystem of tools. So Power BI is part of the Power Platform. You have Power Apps. So Power Apps is a no-code environment for creating mobile and tablet applications that can connect to different data sources and also be integrated with kind of the business intelligence paradigm. They have on Azure different services that you can connect to for machine learning, and Azure itself as being a framework for spinning up different services is extremely kind of interesting. So they really are curating this ecosystem of modular components that can really build on the idea that their potential surface area is very large, and they can start to deliver these capabilities to their users that are approachable and accessible, and again target both the technical and non-technical groups. There's likely much more to come, and probably a lot that I'm not aware of in that space.
Cool. I think we're good on questions. Thanks, Nate.
Great. Well, thank you. Just to, as people start to trickle out, maybe I'll just quickly go through the last couple of slides here, just related to where you can find more about kind of our work and learn more about the Proving Ground apps, specifically Tracer and Semantic. So we do have a website, obviously, apps.provingground.io, where you can download trials of these tools, take them for a test whirl. And if you like it, please support us. And we right now we offer off the website a perpetual licensing model, so you can download a seat of Semantic and seat of Tracer, and have access to the 2D and 3D visualization and harvesting components for each one. And we also have kind of more on a case-by-case basis, and through kind of a dialogue with you, we'd also do offer like these enterprise consulting services where we take the core technology and really help scale them up to your organization. So, we look at subscription licensing, bulk licensing, we'll do training, we'll customize infrastructure for you for setting up ways with which you're harvesting this information, and also offer other services that may be tailored to your need. For students, this is very popular at the moment. We get a lot of inquiries, and we're seeing a lot of uptake here, both with Semantic and Tracer, but also Conveyor. We have a bundle discount. So if you pick up all 3 of our apps for students and you provide us with information about where you're studying and evidence that you are a student or a teacher or a researcher, we provide a 93% discount. So they're not free, but it makes the uptake of these tools in the academic context far more palatable for folks. We have a lot of documentation on these tools. You can download free templates on connecting to kind of harvested data out of Revit, for example, and kind of getting an idea and getting a sense of what types of relationships are possible in Power BI with our business intelligence strategy. And then we also have a lot of stuff on YouTube, kind of on-demand tutorials, training, and webinars like this are recorded as well. So we're really growing not only the kind of idea of the product and the concept of how business intelligence is used in this context, but we're also trying to create stuff that can really help support our users in understanding how these things can be applied. So with that, we can conclude our presentation today. If you have any questions, feel free to reach out to me. We have contact info on apps.provingground.io. Take the tools for a spin, reach out with questions. This is recorded. I'll let everyone know that attended when the recording is available. And for those who weren't able to make it, of course, we'll be able to review it as well. So thank you.